About two types of matrices, what we call a zero matrix and what we call a unit matrix. Okay, so let's start with a zero matrix. A zero or null matrix, it's also known as a null matrix, has all its elements being equal to zero. So that's what we call a zero or a null matrix. All its elements are equal to zero. Now if you add any matrix or a matrix A to a zero matrix, you're still going to get that matrix back. So if you have your matrix A and you add it to a null matrix, obviously A and the zero matrix O should have the same order. So what you're gonna get is matrix A. For example, if you have your matrix 1 2 3 4 and you add it to another 2 by 2 matrix with elements 0, which is a zero matrix, then if you add each of the elements in matrix A to the zero elements in matrix O, which is our zero matrix, you're still gonna get the result as the matrix 1 2 3 4. So adding a matrix to a null matrix or a zero matrix won't change the matrix. Another important thing is if you multiply a matrix by a null matrix or a zero matrix, like we said, you are going to get a zero matrix. Alright, so remember we talked about multiplication. Let's say you have your 2 by 2 matrix 1 2 3 4 multiplying the null matrix, which is a 2 by 1 matrix 0 0. If you are to multiply a row and column, remember how we multiply the two matrices. It's a row times column. That means that all the elements on the row will multiply all the elements on the column. In this case, the result is still going to come out as 0. And next we multiply this row by this column again, and still what you're gonna get is 0. So the solution here will come out a null matrix, a zero matrix, which is a 2 by 1 matrix 0 0. So multiplying a matrix by a zero matrix will give you a zero matrix as the solution. Let's go on to unit matrix. A unit matrix is also called an identity matrix. It is a square matrix with its leading diagonal with values of 1 and the rest of the values are equal to 0. So what's important for you to note here is that a unit matrix or an identity matrix is a square matrix, right? Remember we talked about square matrices as we were introducing this topic on matrices. So it's a square matrix and its leading diagonal has values of 1, the rest of the values are 0. Let me give you an example of a unit matrix. The matrix 1 0 0 1 is a 2 by 2 unit matrix. The matrix, this 3 by 3 matrix 1 0 0 0 1 0 0 0 1 is a 3 by 3 unit matrix, right? So if you look at both unit matrices, you find that this diagonal, this leading diagonal, as we call it, has got values of 1 and the rest of the values are equal to 0. So that's what we call a unit matrix or an identity matrix. Most of the time it is denoted by the letter I. So the letter I denotes a unit matrix. Now if you multiply any matrix by the identity matrix or unit matrix, you're still gonna get that matrix back. So matrix A multiplied by matrix I gives us matrix A. Why? Because the matrix I, the identity matrix or the unit matrix, is a unit matrix. If you multiply anything by a unit, in mathematics, the unit is the simplest form of any value of any measurement, then you're still gonna get that value. If you multiply, in this case, a matrix A by a unit matrix I, you're gonna get matrix A. And also another very important point is, if you multiply a matrix by its inverse, in this case we've got matrix A multiplied by its inverse, A inverse, the result will come out a unit matrix I. Let's have an example for what we're talking about. If you have your matrix 1 2 3 4, that's a 2 by 2 matrix, multiplying it to a unit matrix. Remember, the matrix 1001 is our 2 by 2 unit matrix. Then you're still gonna get the result as the matrix 1 2 3 4. You see, this matrix is not gonna change because you're multiplying it to a unit matrix. So you're free if you want to multiply row by column until you get your solution. You're gonna find that you're still gonna get the matrix 1 2 3 4, right? And if you, so that is matrix A, right? And if you have your matrix A, remember we talked about how to find the inverse of a matrix. The inverse of A will come out as A inverse is equal to -1/2 and 4 -2 -3 1. So we have here a matrix and its inverse. Now if you multiply matrix A by its inverse, which I want you to do on a piece of paper by yourself, then this is the product, and you start by multiplying these two 2 by 2 matrices. For the purposes of this video, I'm not going to do that in showing all the working, but I would want you to do the working yourself, right? So we have these two matrices, you multiply them first, and what are you gonna get? Alright, I'm gonna get here -1/2. The product of the two matrices, 2 by 2 matrices, will be having -2 0 0 and -2 again, right? And if we are to simplify, because we have this scalar -1/2, if you multiply -1/2 by each element within the 2 by 2 matrix, the product that we have obtained, you're gonna find that we're gonna get our solution coming out as our identity matrix, right? So what that proves to us is that if you multiply a matrix by its inverse, what you're gonna get is an identity matrix. A very, very important point. Now this is going to be useful because we're also going to learn how to solve simultaneous equations using matrices. So you're going to find that these 2 points that we've just talked about will be quite useful. Alright, so thank you for watching this video. I'm going to be giving you some examples, and we're going to be applying also these 2 principles that we have discussed about in this video in solving more problems.